In this tutorial, we will learn how to create a Google Developer account and enable Google Photos API and OAuth Consent Screen. To start, go to developer.google.com and click on the Start button. Provide all the necessary information to create an account. Once the account is created, go to console.cloud.google.com. Accept the terms and conditions. Select Create a new project and click on the Create button. Since it's a personal project, there is no need to select a location. Wait for the project creation to complete, then click on it. For our project, we have to do three things here: API and services. As we want to access Google Photo from the user, we have to enable Google Photos API. We have to set up the OAuth Consent Screen. As we are going to use a web application to get access to the Google Photos account, we need an OAuth Consent Screen to get that access. This is how the sample OAuth Consent Screen looks. We have to create credentials. We have to create our secret keys to verify our identity with Google. To enable the API, go to API and Services and select the Google Photos Library API. Enable it. Now we need to enable the OAuth Consent Screen to request permission from the user to access their Google Photos. Since we are only testing at this point and don't have any organization, we can select External and then click Create. Next, we need to provide some basic app information such as the app name and email ID. If you have any links you want to provide, you can add them here as well. You'll also need to provide developer contact information, which can be any valid email address. Once you've entered this information, click Save and Continue. Now, we need to select the scopes we want to request from the user. Scopes are essentially the types of information we are requesting from the user. In this case, we want to access the user's Google Photos, so we will select the scope related to Google Photos. Different scopes are available for different use cases, such as Google Drive, Read-Only, or Write Access. Search for Photos and select Read-Only Access. In the next step, we need to define which users we want to test this application for. As we are still testing, we can add up to 100 email IDs. For now, we will use the same email ID that we are testing. Once we publish our application to production, we will have more access. Now it's time to check all the information before creating credentials. Return to the dashboard and click on Credentials. These credentials are like secret keys that allow us to access the user's Google Photos. Since we are using a web application, we need an OAuth Client ID. In the Authorized Redirect URL field, we need to define the URL which we want to shortlist. When we go to the OAuth Consent Screen and Google asks for the email ID to select, Google will redirect back to one of these authorized domains. We need to whitelist this domain to tell Google that it is a valid URL or endpoint that can be trusted. For testing purposes, we can use localhost 4040 some endpoint and click Create. Finally, we need to download and save the client ID and client secret somewhere safe. This information should not be shared with anyone else. With everything set up, we can now request permission to access the user's Google Photos. Let's see what the process looks like. To pull Google Photos from our Telegram bot, firstly, we need to use the client data and secret to obtain a login URL. This URL will prompt us to select the Google account from which we want to pull out Google Photos. Once we choose the account, we will receive a code, which is just a secret string. Next, we use this code to obtain the refresh token. With this refresh token, we can then obtain an access token. Using this access token, we can access the Google Photos of the user. Although the process may seem lengthy, we can simplify it by writing some code. We can begin by creating a file called OAuth and a folder called config, where we can paste the credentials we downloaded earlier in a file called config.json. In the OAuth file, we need to import the Axios library and the config we just copied. After importing these, we can create a function called getNewLoginURL and export it. This method will enable us to obtain the login URL. In order to get the URL, we must make a call to the google.com API and include specific parameters. These parameters include the client ID that was obtained from the configuration, the redirect URL that was provided when creating the OAuth Consent Screen, the access type which should be set to offline, the response type set to code, the scope that was selected when creating the OAuth Consent Screen, the state set to the new access token, and consent prompt. Here we are returning the Axios instance. To test this method, we can add a condition in our index file. If the request URL is /test, we will return a string. Once we run the server, we can hit localhost 4040 and /test in the browser to check if it is working. Yep, it is working, but we see there is an error in our console and the server got stopped. Let's find out why. Let's try to debug the code. For that, click on this debug icon, click on Run and Debug, and click on this debug console. Now we should see the debugging toolkit. Let's keep a breakpoint here, and let's hit it again. Now if we see the request.url coming as a test, which is expected behavior, but again, this handler got invoked. Now we are getting a request for the fav icon, so when our browser requests something, it automatically asks for a fav icon. Let's handle this case. Go to our index file. Here, along with the handler request, let's send which type of method. This is a post call. This is a get call. Now our handler will just simply check if the method is get, then we'll check this condition. Any other get request will simply return this string, unknown request. Let's test this logic by restarting our server. Now let's see what data we are getting from the getLoginURL method. Let's debug this code. Awesome, we can see the API is successful and we are getting URL inside data/config/URL. Let's return that URL. If you take a look at the URL, you'll notice some spaces between the query parameters. It's best to remove them. Once you do, you'll see the correct URL. Open it in a new tab. It will prompt you to select your Google account. Choose the account from which we want to pull Google Photos. Since we selected testing when creating the application, we'll receive a warning. However, we can proceed for now. Fantastic. You'll notice that it returns to the gToken path, which is the redirect URL we previously provided. In the query parameters, you'll see that it returned the code we were anticipating. Now let's see how we can obtain the refresh token using this code. Let's create a new function called getRefreshToken inside OAuth.js and export it. To obtain the refresh token, we need to make a POST API call to Google. To do so, we must send the following parameters: client ID, client secret, code, the code we obtained earlier from the URL, grant type, set to authorization code, and redirect URL. Now let's create the Axios configuration. Set the method to post and the URL to google-apis.com/token. Add the headers and parameters we created earlier. Next, let's hit the API and return that instance. When the user selects their account in the browser, it redirects to the endpoint gToken. Let's listen to this path and extract the code from it. For now, let's return an empty value and debug the code to see what data we're receiving. When we refresh the browser, we don't see any breakpoints. Let's set a breakpoint at the beginning of the function and try again. If we refresh the browser again, we can see the breakpoint. The method should be get, but the URL has /gToken and also some query parameters attached. Let's check for an index of in the URL and test it. We can now see that the query parameters contain the code. Let's import our getRefreshToken method and pass the code to it. Since our getRefreshToken method returns an Axios instance, we must wait for it to finish. The code may have expired, so let's get a fresh code. Let's obtain the refresh token from the response. Since our application is in the testing phase, this refresh token will expire in 5 days. Therefore, we need to obtain a new refresh token every 5 days. In future tutorials, we'll explore how we can use our Telegram bot to automate this process. For now, let's save this refresh token. So far, we've been able to obtain the login URL using the client ID. Using that login URL, we obtained a code. Using that code, we obtained our refresh token. Now let's explore how we can obtain an access token using this refresh token. Let's create a method to obtain an access token in our Google Auth file. We'll receive the refresh token as a parameter. In this method, we must call the post API with the following options: client ID, client secret, refresh token, the refresh token we obtained earlier, and grant type set to refresh token. The Axios configuration should have the method set to post and the URL set to /token. It's similar to the getRefreshToken method, with the only difference being the grant type. Let's call Axios and export this method. To test this method, let's create a new endpoint for testing. This is the refresh token we obtained earlier. Let's call the getAccessToken method by passing this refresh token. Let's debug to see what we're receiving. Our access code looks the same as the refresh token. After cracking my head for some time, I got the issue. To explain, let's set a breakpoint inside /gToken and rerun the entire process. If we look at the refresh token data, we have the access token and refresh token. We can obtain the access token here, but it's only valid for 3,599 seconds. That's a short-lived token. That's why we'll take the refresh token here and save it. Refresh tokens are valid for a longer time. In our testing phase, they're valid for 5 days. If we submit our application in the Google Developer Console, then Google will verify the app and make it production. Then our refresh tokens will be valid for a very long period of time. Let's take a refresh token here and save it so that we can obtain a fresh access token whenever we need it using this refresh token. Let's change our code accordingly. If we hit this endpoint again and again, we'll obtain a new access token that we can use. Now let's explore how we can obtain the user Google Photos using the access token. Before that, let's go to my Google Photos account. So in this account, I have 17 photos uploaded. Each photo is called a media item in Google Photos. So let's see which API we can use to get these items. For that, let's search for Google Photos and API media items and go to this link here. If you see under the media item, these are all types of APIs that we can use. Right now, we are interested in the list API, which gives us all the images in one list. Let's close this sidebar. This API is a GET request and has query parameters such as page size and page token. Page size refers to the number of media items we want to fetch in one request, and page token I will explain in a bit. Unfortunately, this API can only return a maximum of 100 media items at a time. If, for example, we have 200 photos in our Google Photos, we will need to call this API twice, with a page size of 100. The response body returns an array of media item objects and a next page token. The media item objects contain unique IDs for each photo, as well as other relevant information. The base URL is the only information we require, as it is publicly accessible and provides access to the image in Google Photos. We can try out this method to retrieve the media items from our Google Photos account and see the unique IDs and base URLs. This gives the image in that Google Photos. Okay, now if I collapse this, you see we just got the responses, media items here. I didn't use any page size. As I said earlier, in my Google Photos account, there are 17 photos. Now let's give the page size as 10. So I'm asking Google Photos to give 10 photos in one shot. Now if I execute this, it gives the 10 items. And also it gives something called the next page token. So basically it is telling, these are the first 10 items, and if you want the next 10 items, use this token. So we have to call this API recursively if we want all the photos. So this next page token is something we will pass in that page token in that request body. Now let's write some code to get these photos. Go to our editor and create a file called Google Photos. So to make the API calls, let's import the Axios library and let's create a method, getAllMedia, and export that. This method requires 3 arguments: the access token, the page token, and the page size. The access token is the token obtained earlier. The page token will be empty for the initial load and subsequently added recursively. and the page size is the number of items to be retrieved in one request. Let us gather all the images we receive from the API and place them in the final set. To execute this API call, we need specific parameters. Firstly, the page size, which would be 2 in this case, and secondly, the page token. During the initial load, the page token is empty, and we add it recursively. Lastly, we require the Axios config. Our method is get, and we have the URL from before. In the headers, we must send a new header named authorization. The value for this header should be bearer space access token, and the content type should be application to a JSON along with the parameters. As this is a promise, we will reject it if an error occurs. Once the promise resolves, we will get all the media items from the response, and we will then push the base URL of each image. Then we will check if there is any next page data. If there is, we will receive a token, then we will have to call this method again. If there is no page token, we can resolve the final set of data we have collected. If there is a next page token, we will call the getAllMedia function again by passing the access token. We will then append whatever data we receive from that method to the existing final data and resolve all the final sets. To dry run this code, let us take an example page size of 10. As there are 17 photos in our Google Photos, by default, the page token will be empty. The first 10 media items will be pushed into the final set, and there will be a next page token. So this method will be called again with the next page token. This process will repeat until we receive no next page token, and we will resolve all the data we have collected. We will then append the remaining data to the existing final set. Therefore, we will have a total set of 17 base URLs. To test this, let us create a test route, import the file, and call the getAllMedia by passing the access token. Then, we will return the data we receive. We can see all the URLs and each item is an image. To summarize using the client data and secret, we can get a login URL. Using the login URL, we can select the Google account from which we want to pull our Google Photos. From that account, we will receive a code. Using that code, we will get our refresh token. Using our refresh token, we will get our access token. Finally, using this access token, we will call the Google Photos API to get all the photos from the user account. So right now, everything is at pieces. We are getting login URLs at one endpoint, and we are getting images at one endpoint. In the upcoming tutorials, we will streamline this process using our Telegram bot. But before that, let us see how to set up a Postgre database so that we can save some of the information we need. Thank you for tuning in. I will see you in the next tutorial.